Record this computer. All right. Today is the 16th. What we've got going on today is we're going to finish up. We got chapter number 8, where we will be talking about oxidation reduction. Then I wanted to make the announcement that your practice exam is up. I wrote that and I wrote your actual exam at the same time yesterday, or finished them yesterday. I wish that I could do them very quickly, but I have a very bad habit of writing like one question and then getting distracted. Um, and then going back and planning like how should I write the exam? Ooh, how should I write the exam, Joel? That's a good question. So at any rate, the practice exam is up. It's available for you guys to use. I think I posted an announcement with a link to it, so you don't have to go scrounging and searching around for it. Could anyone confirm in the chat if I did post an announcement or if they saw an announcement about the practice exam? Awesome. Awesome. Okay. So that's great to hear. The next thing is just getting started. Can you tell us again how the great, you know what? We've got the time. Well, Ashton, I'm happy that you are incorrect because um, I would not be, I don't know, I always have to like double check my exams, and so I have not done that yet. So I think that it's totally relatable that you also were not, or yeah, not ready for the exam or are relieved that we do not have the exam today. I got a private message question about grading. And yes, I can absolutely go through that. Because we've got the time right now. Um, and so I don't want to also leave it till the end. So grading. And what I'm going to do is just look at, and I'll play around with some numbers here. So exam 2, exam 3, and the final. Um, And so I'm going to look at each one of these things as groups. And I can't remember the exact number. I think it's 15%. It's on the syllabus, and I've got it set up on our Canvas gradebook to do this. But every time we take an exam in this class, um, you get a score. And I'll put that into the grade book. And let's say that the first exam that you took, you got an 85. Then exam number 2, let me rewrite that so it's a little bit more clear. 85. Exam number 2, let's say that you got a 90. And then exam number 3, let's say that hypothetically, and I'm not dooming everyone to this or anything like that, but let's say that for exam number 3, you decide, you know what, I'm just going to focus on the final, and you get a 55, so a low number there. Again, I don't want anyone to get a 55, but I'm just giving this hypothetical. Then on the final exam, okay, the final exam, actually, the first thing that I want to clarify is that is mandatory, or it is a part of your grade. It accounts for 15% of your grade. I'm changing colors on all these so that maybe it will make a little bit more sense. So we've got a color coding. Let's say on the final exam, you just wipe the floor with it, or mop the floor with it. Let's say you got a 92. Okay, so here's the way that the grading works out. Exam number 1, that's a group within the grade book. That group is worth 15%. All the while, whenever you've been taking exams in this class, and so far we've only taken 2, but I have added the successive exam, so the exam that follows, into the category or into the group with the previous exam. So what that means is the 15% that corresponds to exam number 1, you'll actually see 2 grades there. You'll see the 85 and the 90 that you got on exam number 2. At the end of the semester, you will also see the 92 that you get on the final exam. Okay, now I'm just going to go ahead and could I get a response in the chat? Is everyone clear on that? I haven't talked about dropping anything or anything like that, but I'm putting all of those grades grouped together. Okay, so okay. All right. If at some point you get confused, let me know. And I got a private message question of, am I going to average them? I'm going to take the highest. Okay, so now when we look at exam number two, what you'll see there is you'll see the 55 that someone got, this hypothetical student got on exam number three grouped there. Then they will also see the 92 that they got on the final. For exam number two, you will see the 55 and the 92. Okay, so looking at all of these groups, let's start with the final. The final, that is 15% of your grade. That's not negotiable. You have to take the final. If you do not take the final, effectively, you'll get a zero for 15% of your grade, which if you get a zero for 15% of your grade, basically the highest that you can get on for the class is an 85. There has been some extra credit, but that's pretty much your ceiling. Can I get a Y or an N if everyone is clear that the final is required? And if you do not take it, basically the highest you can get is an 85-ish. Okay. I also saw a question about when is the final, and I'm going to pull that up in just a second. Okay, so it seems like everyone's good that the final is mandatory. Now, what is not really something I'm going to deliberately do, it's not going to be like, hey, everybody, I've done this. Um, Whenever I finalize grades, I send out an email and I give a detail like, hey, the final exam average was this. Here's how you can process, here's how you can read the grade. Um, but what is going to be automatically done is exam number one here, the 85, 90, and 92. The 85 and the 90 will automatically be dropped because those are the two lowest grades. So essentially, if you did bad on exam number one, but you do really well in the final, that is basically erased by the final. Exam number two, 90 and 55. Those are effectively erased by doing well on the final. Exam number three, the 55 is essentially erased because you did well in the final. So this is a point that I want to make, and then I'm going to play around with some different numbers. If you do better on your final than any of your other exams, that means that your final exam score accounts for about 60% of your grade. Can I get a Y or an N confirming or disconfirming you understand that? Okay, awesome. So if you do really well on your final, then awesome. Um, Now I'm going to give you some different numbers. Let's say you have another class that you're like, I've got this accounting class. I'm really concerned about that. I'm going to work really hard on that. And you know what? I've done pretty well throughout throughout 1310 or Chem 1310. And I'm just going to kind of wing it. And let's say you wing it and you get a 70. I'll bring that 70 and throw that here, here, and here. That 70, when we look at exam one grades, well, that 70 is going to be one of the grades that's dropped. The 70, then here and here, and then here, it will be the kind of elevated grade. I got a question in a private message. Do we get a note card on the final exam as well? Absolutely. You can still use one of the 3x5 note cards. So in this case, where the final was only your final exam score was only higher than one of your other exams, can somebody add into the chat what percentage of your grade is determined by the final? It's a little bit tricky. Sure, it's the 15, but it also replaced exam 3, so it's 30. Absolutely, 30%. Will there be a practice exam for the final? There will. Okay, so in the event, now let's go with one last example. Let's say that you just you or somebody just says, forget it. I am going to just go and I'm going to answer the first question on the final and then I'm going to submit it. And that person gets let's say they get a 2 on the final. 2 will be dropped. Does 2 still count towards your grade? Sorry, it's not dropped there. It does. It still bears 15% of your grade, or it still accounts for 15% of your grade. 2 is effectively a 0 for all intents and purposes. The practice final, I'm hoping to have up shortly after um, exam number 3. If I get it up before then, I will let you guys know. But I'm going to go with the same sort of thing, you know, in terms of number of attempts that you have on the practice final. And then the last thing, and feel free to add questions. I'm going to look up our final exam schedule. I'm going to copy the link into the chat. So that link right there will take you to the final exam schedule. And what is a little bit tricky about understanding this or reading this is that, let's see. Our class is Monday, Wednesday, 9:30 a.m. Let's see. Okay. So I'm going to share my screen on this one. All right. So this table is good. But it can be kind of hairy. Our class is a Monday, Wednesday class. And so a fair question then is, well, where? Huh? It's a Monday, Wednesday class. And if you scroll through this list and you look and okay, there's Monday, Wednesday, Friday. We're not a Monday, Wednesday, Friday. We're a Monday, Wednesday class that meets at 9:30 until 10:50 a.m. If you look at those Monday, Wednesday classes there, and then if you look at them here, you won't find our class. And the reason for that is our class time is a non-standard meeting time. And so our class starts before 10 a.m. And so our final exam is Wednesday, April 30th from 8 a.m. until 10:30 a.m. And I believe that is the very first day of finals. Yeah. So, anywho, I think those are pretty much the big points about the final. Does anyone have any questions about the grading or the final exam? This web page here I think is helpful, but it is also like I've worked at Texas State since 2013, and this is something that I have to like every semester whenever I revisit it, I'm like, okay, what am I looking at? What am I looking for? Sort of thing. So it's a lot of information to process. Sure. The exam time, actually, let me write it down. Our final, nope, not that. Final is Wednesday, April 30th from 8 o'clock until 10:30 a.m. And it will be on Proctorio, just like all of our other exams have been. Okay, cool. And Monday, we're going to be reviewing for exam number 3, and then the next Monday, which will be April 28th, we will be reviewing for the final. Oh, the final exam is usually between 80 and 90 questions. If it's a little bit longer or shorter, I'll let you guys know. And I wouldn't expect it to be any longer than 90 though. We have a longer time frame for it, and I want to give like whenever I'm writing the final exam, I always want to have like a balance of like the kind of low-hanging fruit, easy questions, but then also some that are a little bit more challenging. So the way that I do that is with volume, just to get lots of stuff in there. Um, and basically yeah, so about 80 questions is usually what I end up at because of, in-class exams are 40 each. And, good study ideas, you have access to your old exams. Look at your old exams. I always repeat some questions. If I don't repeat a question directly, then I'll take a question and just kind of like reconfigure it, Frankenstein it into a new question. Okay. Well, here is where we are going to go. Oxidation and reduction. Can I get a Y or N in the chat if you have no card is allowed. Um, Again, I'll talk about the final exam a week from Monday, or more about the final exam. Okay, so could I get a Y or an N in the chat if you have ever heard of oxidation and or reduction for that matter? Okay. Now this is a topic. There's a couple of things in general chemistry and like a first semester chemistry class or an IPC class that are like these are kind of the topics that stump folks. And whenever I say stump folks, I mean younger Joel. The first time I was ever exposed to these terms, I was just like, what? I don't, oh. This is kind of like the mole. It's almost like treated as a proving ground of sorts. So, oxidation reduction, people combine them and make this term redox. There's a difference between a redox reaction, which is a reduction or oxidation reaction, and an acid-base neutralization reaction. The biggest difference is whenever we talk about an acid-base reaction, we're talking about movement or the transfer of a proton, so H plus. Whenever we talk about an oxidation or reduction reaction, we're talking about an electron being moved. Now, if you think about an electron, um, you probably think about if you think about an electron, you're probably thinking about a subatomic particle. And you're absolutely right. Atoms can lose electrons and form ions. And what this right here is showing, this one on the left, I'm drawing with a black pen over a black background. This is showing how violent a redox reaction is. On the right-hand side, we're mixing vinegar and baking soda and effectively making what, my kids who are in elementary school see as a volcano. Mix those things up and oh man, it's awesome. Gas is formed. Well, redox reactions are the transfer of electrons and they can react very violently and cause explosions. Now, whenever you think about an oxidation reaction or a reduction reaction, you've maybe heard of this mnemonic. Leo the lion says grr, or being in Texas, another mnemonic that folks often use is oil rig. And these mnemonics are useful because they give a definition for what oxidation is. So, one example of oxidation that you might be familiar with is when something rusts. So, a bike chain is a great example. Whenever that rusts, what's happening is the metal is getting oxidized. And a classic example of that is Fe, or elemental iron, solid iron, will get oxidized and form a compound like FeS. Now, in order to do that, iron, this Fe, which has a charge of zero, so it has an equal number of protons and electrons, forms FeS. Well, if you look on the periodic table, you'll see that S has a charge of 2 minus. Does anyone know what the charge of Fe is as a result of this? If the overall compound is zero, add to the chat what is the charge of Fe in a compound like FeS? S is 2 minus, so absolutely. Iron, Fe has to be 2 plus. So in order to form that compound, we have to have, well, Fe that's 2 plus and S that's 2 minus. And whenever something goes from Fe to Fe2 plus, well, it's lost 2 electrons. Now, this mnemonic, oil rig. Oil stands for oxidation is loss. Then rig, reduction, is gain. So when something gets oxidized or undergoes oxidation, well, then one thing that might be happening is it's gaining oxygen. Another thing is it will lose electrons. So when something gains oxygen, it has to lose electrons in order to make room for that oxygen. In addition to that, its oxidation number will increase. So think about this as how negative it is. The magnitude of that will increase. Reduction is gain. Okay, so in order for something to get reduced, it will gain electrons. Could somebody add to the chat, what's the charge of an electron? Minus one, absolutely. So if I gain electrons, and I always like to think about it like this, let's say that Joel, that's my name, if I gain an electron, would everyone agree that this right here is a like math representation of me gaining one electron, a Y or an N? Does everyone agree that that is me, Joel, gaining one electron? This is a little abstract, but so if I gained an electron, if I gained a negative charge, well, then something that the product would look like is Joel minus. So I'm more negative. When you gain an electron, you get something that's more negative. Whenever you lose an electron, you get something or you become more positive. So increase in your oxidation number. I'm sorry, I was saying that you become more positive, whereas a decrease in your oxidation number, you become more negative. Now, to illustrate this, got a poll question that I'm going to pull up here. As soon as polls works. There we go. There we go. We're getting there. Boom. Now, is anyone going to answer before I actually show the question? We're looking like no. Yep, somebody did it. 2 people did it. 3? Why are you doing this to me? I haven't even shown a question. Oh my gosh. There's our question. Our question is, in the reaction 2H2 plus O2 yields 2H2O, hydrogen is, okay. So could anyone add to the chat? We're going to work through this all together. What is the charge of hydrogen in H2? And then, same answer, what is the charge of oxygen in O2? So we need to figure out our charges for H2 and O2. And let me just go ahead and tell you, H plus is not H2. So our charge for hydrogen here, H2, 0. Each hydrogen there has a charge of nothing. What about O2? Oh yeah, I said that was the same answer. O2 is going to have a charge of 0 as well. Now, both of those have a charge of 0. The question is about hydrogen. Is hydrogen getting oxidized or reduced? Well, let's think about this just from the charge perspective. When we look at H2O, well, we know that oxygen, and we know this from the periodic table, we know that oxygen has a charge of -2. That's from the periodic table where it is. It's in group 6, and we know that it's got to pick up 2 electrons. Okay? So then if oxygen is becoming more negative, it gains electrons. Hydrogen, well, hydrogen has to become H plus. Therefore, each one of those went from 0 to +1. So they lost an electron. And so I got a private message from somebody who I think was just saying, like, listen, listen, listen. I did not answer it before the question showed up. Or they're saying, hey, I did, but my actual answer is A, oxidized. If you got A, oxidized for this, you're correct. If this question was about oxygen by comparison, well, then the answer would be it gets reduced. One thing to keep in mind and one thing to remember about oxidation reduction reactions is if one thing gets oxidized, the other thing gets reduced. Now I got a private message. Yes, it doesn't it mean it's getting reduced because O2 and it is -2. Yes. Well, yes, O2. Yeah, yeah. Wait, how do you know it gained an electron? Great question. So the way that we can deduce this is we can look at the periodic table. And what we want to do is look at the periodic table. Let me actually pull up the periodic table real quick. And we'll do this as a little bit of a refresher, and we'll go through a similar sort of reaction. So could I tell by the coefficient if it gained? The coefficient isn't going to help you out with that. So that's a great question, but the coefficient can't really help you out with that. In order to solve a problem like what we saw right here, what we have to know, what we have to be able to reference is the periodic table. And what we have to be able to do is to go back and say, all right, well, I know the common ions that form in this row, or this row, or this row, or this row, or heck, over here. Now, can anyone tell me, and whenever you're thinking like, what common ions, what, just a sec, stop the press. Um, the common ions in the column where oxygen is. We've got sulfur, selenium, tellurium. What common ions? What is the charge of the common ions in that column? That column is also known as the fun word here, chalcogens or C halcogens. What's the common ion? Well, those are typically going to be -2. Now, what is the common ion of something like Nitrogen. Add it to the chat. -3. Boom. Emily. Perfect. Great job. What about chlorine? -1. Okay. What about magnesium? Mg. +2. What about potassium? K. K. Perfect. +1. I always like to think about potassium because that's the most common way that I communicate in text messages. Just K. K. So, with that in mind, you need to have that periodic table as a good reference point. And so if you were to see a problem like this, I'm going to say N2 plus H2. That's nitrogen gas reacts with hydrogen gas. Those two will come together to make NH3. I don't care about balancing them. What I do care about is, do these things, okay, why is 2H2 neutral? Well, H2 and N2 and O2, those are diatomic gases. So from an electron standpoint, each of them rolls up. Like here, we'll look at H2 as an example. Each hydrogen atom rolls up with a single electron. And what they do is they just share them. And you look at H2, N2, O2, any of these diatomic gases, any of these diatomic molecules, and you say, well, the hydrogens in H2 are effectively identical. And what I mean by that is there isn't one that's positively charged and the other it's negatively charged. Instead, they both have a charge of 0. Does that help explain? Does that help at all? So if we look at this at the bottom, what's the charge of nitrogen within N2? Or what's the overall charge of N2? Can anyone add that to the chat? Oh, and maybe this will help. Um, you're absolutely right. It's 0. Whenever we identify a species with a charge, whether that's a diatomic element or a polyatomic element, we're always going to say like plus. And whenever it's not indicated, you can assume that, oh, it has a 0 charge. So now, Dolce, I'm gonna put this to you. What is the charge of H2? Perfect. So both N2 and H2 are neutral. They are diatomic gases. Those two atoms love to interact with each other and both have a 0 charge. Now, NH3, this compound over here. Well, my first question is a charge indicated here? No, it's not. And that's not a trick question. So the overall charge on this species of NH3 is 0. Now, with that, since these are different atoms, what you need to do is look at it as, well, N, basically treat it as a math expression. The sum of the charges is equal to 0. Can I get a Y or an N if you get that? Okay. So whatever the charge of this nitrogen and the charges of all of these hydrogens within this molecule, which let me erase this. Those will be added up and equal zero. So the question is, let's look at, or I'm going to show you guys kind of what's happening at like a molecular level when we think about the balanced chemical reaction. N2 looks like this. Nitrogen or N2 gas has a triple bond between each of those atoms. Hydrogen gas has a single bond between each of those hydrogen atoms. A certain number of these and these will come together to give us a molecule that looks like this. Now, this molecule right here and this molecule right here, the identity of the atoms in those two molecules, they're the same. And whenever you deal with a molecule where the atoms are identical, they're both going to have the same charge. And since the overall charge of N2 is zero, well, this nitrogen and this nitrogen, they each have a charge of zero. Each hydrogen has a charge of zero. Now, in order for, change colors there. In order for these bonds and these bonds to be broken, and for these bonds right here to be made, well, the electrons basically have to be rearranged. So all of these atoms, where I put my star up at the top, the N's and the H's, they basically have to break a bunch of bonds and remake a bunch of bonds. Can I get a Y or an N if you follow that part of it? The bond making and breaking. Okay, great. Now, when we do that, does anyone remember what that I okay. When we do that and we make these bonds down here in a molecule like NH3, well, we've got some of these atoms that they bring more electrons in than others. And so what we do is we assign charges to each one of these atoms. And we say, okay, well, the overall charge of NH3 is going to be zero. So what is the charge of this hydrogen, this hydrogen, and this hydrogen, and this nitrogen? And that has to do with basically, is it, that has to do with what we see on the periodic table. So nitrogen, for example, when we looked at nitrogen on the periodic table, what did we say the charge of nitrogen was on the periodic table? -3. Perfect. Okay. So we've got nitrogen that has a -3 charge. That's from the periodic table. So what we want to do is we want to figure out, okay, this is -3. For this whole molecule, this NH3, to have a charge of zero, while nitrogen has a -3 charge, what do we have to have the charge of hydrogen or the hydrogens? Yes, this is bringing back old stuff. What do the hydrogens, what does their collective or their total charge have to be in order for this to be zero? Perfect. Yes. Okay. So can I get a Y or an N if, okay, it's coming back? Okay. Okay. Now, let me, I'm going to insert a blank slide so I can give, kind of a, before we proceed, just want you guys to look at this and put it together. So let's say CH4. When you look at CH4 on the periodic table, what do you identify or what do you see the charge of hydrogen is? When you look on the periodic table, you'll see that hydrogen is in group number 1, so it has a +1 charge. Now, add to the chat, anyone, what is the charge of my overall compound, CH4? That big circle is not a 0, but instead I'm circling where the charge is. You're right. I don't have anything there. I've circled nothing because the charge of CH4 is 0. So what I want to do is say C plus H, I've got 4 of them, equals 0. So blank plus 4 times blank is 0. Well, if I look in row 1 of the periodic table where I find hydrogen, I see that that is +1, or I know that my group 1 elements are +1. What is the charge of carbon in a molecule of CH4? What do I have to put right here in order? Perfect! -4. Okay, now I'm going to give you one more of these, and if I see the correct answer within the first 3 responses, it's a bonus point on the next exam. SO4 is a molecule known as sulfate. It has an overall charge of -2. So think about this as -2. The charges of the oxygens plus the charges of the sulfur. Okay. My question for you is in SO4 2-, what is the charge of sulfur? Add it to the chat. And if I see it within the first 3 responses, and you can private message me. Keep in mind, there's 4 oxygens. We got 4 oxygens. What do we know that the charge of oxygen is? 4 times -2. How did we get the -2? Looking at the periodic table. So based on that, that means we've got blank plus -8, private message +6. Boom! Bonus point. +6. And just so anybody knows, my eyes were blind to any incorrect answers, and was really just pumped that people were responding. So first answer I saw was +6. What's up? What's up? What's up? What's up? Spring break. What's up? Okay. That's what I got. That's my pump up of the morning. Okay. So whenever you see these sorts of questions, which will you have a question like this on your exam? Totally. The reason that you'll have a question like this is because these are, one, they're kind of simple and straightforward questions. They take a little bit of problem solving though. And you have to pull information from like unit 2 and you have to pull this new stuff and it's like, yeah, navigating all of that. So now these numbers or these charges are known as oxidation numbers. There are some rules for oxidation numbers, and I've peppered in a couple of those rules, and those rules are based on, well, a diatomic, or is it diatomic, or is it a, what can you get from the periodic table? Navigating the periodic table is an important part about this sort of problem. Now, as we go, oxidation numbers. An atom in its elemental form has an oxidation number of 0. So what are some examples of an elemental form? FeS, H2, Br2, O2, N2, Cl2, I2, F2, H. Broncliffe. These are our diatomic elements, or diatomic gases. Can anyone in the chat very quickly, and this is for another bonus point, tell me what the charge of, well, let's go with MgS. What's the charge of that? That's magnesium. Solid magnesium. What's the charge of solid magnesium? And a little bit of a suggestion, am I indicating any sort of charge to it? Got that S there. Done. Bonus point. We got 2 on the day. Great job. Does everyone follow that? That's our elemental form. Look out for that. A monatomic ion has an oxidation number equal to its charge. For this, think of the P table, the periodic table. In a compound, hydrogen has an oxidation number of +1 and oxygen has an oxidation number of -2. Boom, forehead tattoo, forearm tattoo, whatever. Though that is a very important value to remember. Hydrogen +1, oxygen -2. Anything else is going to be related to that. So if I showed you something like, well, H2S, you don't even have to look at the periodic table to figure out what the charge of S is. Instead, you should say, okay, well, H2, there's 2 +1s, which means +2. And in order for that to be basically counteracted by sulfur, well, sulfur has to be -2. Set these up as super simple math problems where, oh, what's our charge? Nothing. Okay, therefore, what does our charge need to be in order for this to be 0? The sum of the oxidation numbers of the atoms is 0 for a neutral molecule like H2S, or equal to the charge for a polyatomic ion. So if we were to look at something like, let's go with, no, yeah, no, okay, we'll just go on from it. What's the oxidation number of oxygen in O2? Add this to the chat. Add your letter to the chat. Oxygen in O2. Done. 3 bonus points. Good job. Great job. Who's pumped about bonus points? Me. Look at this. Look at this. Celebration emoji. Thumbs up emoji. What else do we got? Disguise face emoji. My mom always sends me the emoji with glasses, like for anything. She'd be like, hey, Joel, how's your day? Glasses face emoji. And I'll be like, that's good. She'll be like, glasses face emoji. And that glasses face emoji is, let's see if I can find it. I don't know. She might be. That would be like unexpectedly aggressive and like, I'm going to pick a fight with you. Glasses. Oh, I guess it's just an Apple thing because it's not the glasses face emoji that I usually get from her. The only in Zoom here, it's like it's the glasses face emoji with like sunglasses. Okay, now what's the oxidation number of oxygen in H2O? Add this one to the chat. . There might be a bonus point in it for you. We're looking for oxygen. H2O. Boom! Boom! -2. A is the correct answer. Remember, H is +1. O is -2. There's an exception. If H2, then 0. If O2, then 0. You know how I said there might be a bonus point in it for you? I'm going to be generous and say there is. I was thinking for a moment I'd be kind of hilarious and tough and be like, well, there isn't. But I decided not to. So we got bonus point. We got 4 bonus points rolling in our next exam on this one. Okay, now, can I get a Y or an N if you're feeling all right about oxidation numbers and charges? Can I get a 1 if you want to see another example, or a 2 if, no, let's go. Okay, cool. Let's do one. H is +2. Keep in mind, though, there's 2 of them, so each of them are +1. Okay, so let's look at MnO4. 2 minus. So when you see something like this, your first thought should be, all right, my overall charge is -2. So I'm going to set up the equation. I'm going to set up a little simple addition or subtraction equation and say -2. And I'm going to say my oxygens plus my Mn, which is manganese, my manganese plus my oxygens equal -2. What do I know about oxygen? Well, oxygen is always -2, except when it's O2. So this is, I follow the rule, but I know the exception. I know the law, but I know the exceptions. Okay, so it's -2, but then what we've got to do is we got to see, well, how many are there? There's 4 of them. So we're going to say -2. We're going to throw that in parentheses. We're going to multiply it by 4. So each oxygen brings in a -2 charge. So with 4 oxygens and each one bringing in a -2 charge, that gives us -8. If this whole thing has a charge of +2, what is the charge of manganese? Well, manganese has to be +6 or +6. Does everyone follow that? Can I get a Y or an N if you're good with that? Awesome. The trick, I mean, 9 times out of 10, whenever I give you a question like this on your exam, if you remember number 3, you're going to be solid. Because that will like guide you through almost everything. If you can find the hydrogen or oxygen in there, you're going to be like, okay, cool, got it. Oxygen's -2, hydrogen's +1. Everything else is going to kind of contort itself based on hydrogen and oxygen. Okay, so now we're switching gears a little bit. But the reason that we're switching gears is just for a new definition. Oxidizing versus reducing agents. Okay, this is a little bit tricky because we just learned that oxidation is loss of electrons. Reduction, I'm going to phrase it RED, is gain of electrons. Now we've got this new term, oxidizing agent, reducing agent. I always think about this word agent similar to how I think about like a sports agent. I like sports, and so the sports agent is not the person who's out on the field. They're not doing anything. They negotiate the contract. They enable or they facilitate financially that athlete from doing the thing. So an oxidizing agent is the thing that enables the oxidation or causes the oxidation. So when you see this word oxidizing agent, or when you see this question oxidizing agent, it causes the oxidizing or causes the oxidation to take place. And since it causes the oxidation to take place, it gets reduced. So what I would do is I would say OA is reduced. So what does that mean? An oxidizing agent gains electrons. A reducing agent, an RA, I'll say, is oxidized. So a reducing agent loses electrons. So when we look at a question like this, H2 plus O2 yields H2O. How do we solve this problem? This is a process. First step, well, identify which gets oxidized and which gets reduced. Second, as soon as you do that, or in order to do that, identify the charges. Or maybe this is step zero. I don't know exactly, but you kind of bounce back and forth. Identify the charges. What's the charge of H in H2? Add that to the chat. Perfect. What's the charge on O2? Exactly. Now in H2O, what's the charge of H? I didn't say H2 because I wanted to avoid that confusion. What's the charge of H? Plus 1. Okay? So hydrogen goes from 0 to plus 1. If something goes from 0 to plus 1, did hydrogen get oxidized or reduced? It lost the negative thing. So you could look at it almost like this. H yields H plus an electron. It's always confusing because whenever I think of reduced, I think of losing. Because like if I lost 5 pounds, I would say my weight was reduced. But that's one of the places where you got to flip your definitions or hold that to the side. What we're talking about is charges. So hydrogen here gets oxidized because our definition for oxidation is it loses electrons. Oxidation is lost. Or hydrogen undergoes oxidation. That I think is like the biggest barrier because if I, again, like I personalize things and I say, oh, well, if I have 5 Dr. Peppers and I lose 3 of those Dr. Peppers, my number of Dr. Peppers is reduced. But that's where we have to kind of like take a pause and think, what do I mean by oxidation? What do I mean by reduction? So hydrogen here gets oxidized. Therefore, oxygen gets reduced. So since hydrogen gets oxidized, what does that mean hydrogen is? Add your answer to the chat. If hydrogen gets oxidized, that means that it is the boom reducing agent. Can I get a Y in the chat or an N, a Y in the chat if you recognize, okay, I gotta pump the brakes on whenever I think of reduction in oxidation, my like standard definition of reduction. And I've got to kind of contort it to reduction is gaining electrons, gaining negative charges. And that was kind of a long-winded request, but Um, this is what we got going on here. So identifying the reducing agent, identifying the oxidizing agent is a matter of identifying what gets oxidized and what gets reduced. Identify your charges. Then identify which species gets oxidized, which species gets reduced, and you're going to be in a good position to say, okay, well, this thing that gets oxidized is the reducing agent. This thing that gets reduced is my oxidizing agent. Now, one other element to it that people have a tendency to do is they look at it and they say, oh, well, what if I looked at the reaction backwards? Don't do that. Don't do that. Do not do that. Should you do that? No, do not do that. The reason is people say, oh, well, maybe if I do this, why? Don't, don't. I show you, read it left to right. Don't, don't play tricks on yourself. Don't play games with yourself. Okay. In a redox reaction, this is what we see. We talked about an acid and a metal. Here what we got, magnesium going to Mg2 plus. Well, this question is which is oxidized? We've got magnesium, H plus, Mg2 plus, H2. Magnesium goes from being neutral to, well, having a +2 charge. How do you do that? Well, think about this in terms of number of protons and neutrons. I always like to think about, let's just switch this actually. Rather than magnesium, let's think about it as lithium. The reason that I say lithium is because what lithium does is it will form we'll just go with a +2 ion. Lithium has a fairly simple structure. It's got 3 protons. Solid lithium is going to have 3 protons and 1, 2, 3 electrons. That is a lithium atom right there. So what's the charge on this lithium right here that I've got in this big circle? Add it to the chat. What's my charge on that? I've got 3 positives and 3 negatives. What is my overall charge when I account for all of my... Perfect. Perfect. The charge is 0. Okay, now, Emma or anyone else, I'm going to play a little game. Let's say... Now what is it? I've got 3 protons still. How many E... I got a private message that says, what is the... Okay. What is the AQ? That just means that it goes into solution. That just means like it's dissolved. You're absolutely right. The charge is -1. So this right here that I've got drawn in the circle is -1. Now, in order to gain 1 electron here, what I showed, well, that is reduction. Now what I'm going to do is I'm going to erase this, going from Li -1. I'm going to erase an electron, erase my charge. That was oxidation. Now what's my charge of my lithium? Again, 3 protons, 2 electrons. Li plus. So what does that say? Li going to Li plus. Is that oxidation or reduction? O for oxidation, R for reduction. Absolutely. This is oxidation. What I would recommend is whenever you see a problem like this, where I put my star, I would just substitute for something like lithium because it's simple. You can draw it really quick, or you can put something like this on your index card. So now, if in this case, I'm switching these from magnesium to lithium, Li gets oxidized when we move from the left to the right. It's dissolving in that solution. Therefore, H plus gets reduced. If H plus gets reduced, what does that mean? Well, that means it's the oxidizing agent. Okay, now we'll look at basically the same thing. Zn goes to H plus, yields Zn2 plus. Which gets reduced? A, B, C, or D? Spoiler alert, it's nothing on the right-hand side of the question. Oh, sorry. For this question, A is the correct answer. For this question, we have Zn with a charge of 0 going to or making Zn2 plus. Then we have H plus the only reason to account for the S whenever you're looking at this sort of problem is to deduce what the charge is. So when you see that S, you know that it's 0. B is the correct answer here. That is getting reduced because we're going from a positive charge to hydrogen with a 0 charge. Now, whenever you do that, then you can look at this and say, all right, well, which is the oxidizing agent? Well, the oxidizing agent is the thing that gets reduced. Copper, let's see, copper goes from a charge of 0 to +2. So that means copper, solid copper here, lost 2 electrons. So that means that copper gets oxidized. Emily, you're absolutely right. This Ag plus gets reduced and therefore is the oxidizing agent. Okay. Then this, which is the reducing agent? Well, the reducing agent is the thing that gets oxidized. So what gets oxidized here? A, B, C, or D? A. Absolutely. Agents are always on the reactant side. Yep. Yep. So left-hand side, basically, for this sort of question, whenever you see this sort of question, either what gets oxidized, what gets reduced, these two answer options are like total filler. You're really down to A or, well, not always A or B, but you're really looking at the things on the left-hand side of the question. Because Zn is going to get oxidized, therefore Cu is going to get reduced. So the thing that gets reduced is the OA. The thing that gets oxidized is the RA. Now, with that said, you've got an activity this week, and that activity has to do with this right here. Which metal is the most active? And I'm going to undo my pen and I'm going to pull this up and share my screen. Whenever we're talking about an active metal, what we are looking for is, does a metal react in a solution? So the most active metal is the metal strip here: solid magnesium, solid copper, or solid zinc, solid copper, solid silver. If we add silver, a strip of silver to a magnesium solution, what happens? Well, on the left-hand side, we've got those atoms of silver that make up our solid strip. We throw magnesium ions at them. Does silver get oxidized? Does silver give up electrons? No. Thank you, Adrian. That's a forceful no. Yes, it is. Now, if we go back and we reset, let's get magnesium, or let's get zinc. It's okay. It's okay. I appreciate the enthusiasm. Had you said no, go away, then it would be different. Okay. So this is for activity number 20. You're going to click one of these, and did the link on the activity work? If the link didn't work, I'm going to go ahead and just grab this and throw it into the chat, because this one seems to be working. I hope that it works on the activity. But now what we're going to do is we're going to look at the zinc here. Zinc is in a solution with magnesium ions. What happens when a magnesium ion hits zinc? Nothing. Okay, cool. What about when zinc goes into a copper solution? Oh, whoa, 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 whoa. What happens there? What is happening there? Copper ions come in and collide. Oh, the copper is swiping electrons from the zinc. So in this case, copper. Copper is picking up electrons. So is copper getting oxidized or reduced? It's copper, the copper ions gaining electrons. So if you wanted to write that out, it would look like, here's the way that this reaction shows. Cu2 plus Zn. Okay, so those are our reactants. Yields, well, Zn2 plus Cu. Add to the chat, which gets oxidized? Keeping in mind, it's Cu2 plus or Zn. What gets oxidized? What loses electrons? Zn. Boom! Okay. If Zn gets oxidized, what does that mean that Cu does? Gets reduced. Emma, yes! Copper gets reduced and is the OA, the oxidizing agent. Zn gets oxidized and is the Ra. Go through this activity. It asks you to basically take these metal strips and throw them into the different solutions and ask and kind of gets you to answer what is taking place there. Okay. What we talked about today is we talked about lots of different terms. And some of these terms are like, oh, they're almost the exact same thing. Keeping straight when something gets oxidized, when something gets reduced, what that means for it as an oxidizing and reducing agent. The way that I think about it is I start out with this gets oxidized, so it loses electrons. This gets reduced, so it gains electrons. And then that's like what I anchor my ideas in. And then I say, okay, well, the thing that gets oxidized is the reducing agent. The thing that gets reduced is the oxidizing agent. Then I think that this activity is really worthwhile and good. I love these visuals, how it shows, oh yeah, my electrons, they are, well, whenever I reset this and I take a copper strip and throw it into silver, oh, lo and behold, copper in the presence of Ag loses electrons. Or copper ions, sorry, solid copper in the presence of silver ions, well, lo and behold, silver will pick up those electrons. Okay, that's what I've got for today. On Monday, we will be reviewing for the exam. If you've got questions about anything, I got office hours starting at 12:30. If you want to drop by or if you got a question you want to email me about, the practice test is not extra credit, but it's available. So yeah, it's an extra opportunity. But if you get a perfect score on that, doesn't really matter. Not to say it doesn't matter at all. Anyway, today we earned 4 bonus points on our next exam, so that's good. I'll add those in later today. And I do still have to do a lot of stuff with the grade book, so bear with me on that. I can give you a pretty good assessment of where your grade is and maybe what you need to do on the final. But there's still some stuff that I need to sort out. So I appreciate you guys' patience on that. But that's what I got. I hope you have a great Wednesday. I hope you have a great weekend. If you're getting together with family, awesome. Give hugs and don't start fights. That's what I'm going to work on. And that's what I got. Yeah.